Hello. Hello and welcome to this video on JavaScript. In this video, we will look at more methods on arrays. So the first two methods are every and sum. Okay. So if you mouse over this, it will tell you what it does. Okay. So it is a predicate, and as you can see, it takes three arguments: value, index, and array. Now it determines whether the members of the array satisfy the specified test. So this predicate which we are using, x less than 10, is it true for all the elements of the array? So this is the error notation for the function. So we will see error notation in functions video as well. So if you look at the array, all the elements are less than 10. So this will return true. Now sum will check whether some elements, or rather any element, passes this test. So every will return early if this predicate fails, and sum will return early if this predicate passes. So sum will return true in case of early return, and every will return false. So let's see this in action. So let me increase font size, node space arrays 3.js. Okay, somewhere I have not commented. All right. So you see it returns true and it returns true, both return true. Now let's put an element 11. And let's put this element 11 at the beginning. Okay, now every will not return true. It will look at 11 and it will immediately return false. Now, if we remove this, okay, still sum will check whether all the numbers are true or not. Okay, that is, they are divisible by true or not, and it will go through the entire array. In the earlier case, it will look at 2 and it will say that, okay, 2 is divisible by 2, so I'll return true. So that is what it does. Note that every returns true and sum returns false when used on an empty array. So that is an edge case you have to take care of. Because when there are 0 element, it means all elements are passing the test. But sum will return false because none of the elements will pass the test because there are no elements to pass. Now we will come at reduce function. So if you remember my map video, I had written a function with value, index, and the array. So in this case, those become the second, third, and fourth argument. The first argument is the accumulated value. Now this 0 is the initial value. Okay, so let's remove 11. And the sum would be 15. 1, 2, 3, 4, 5 would be 15. Even if you remove this 0, the sum would remain 15. Okay, but the reason of passing this initial argument is that if the array is empty, then it will cause a type error. So we'll see that in a bit. Similarly, this will find the maximum of the array, right? And if you have a positive array, you can set it to -1, right? Or if you have all positive numbers, then you can set it to 0. So let's run this and then we will see the empty array. So it has got 5 and 0. Okay, so this becomes total value. This becomes the accumulator. So we don't need to pass that. Now let's invoke this on empty array. We'll see the problem. So you see, the first one works. It gives you 0. But the second one says return of empty array with no initial value. So in this case, what you can do is, if you know that an empty array is possible, you give it -1. reduce of empty. Yeah. So there is no initial value. The one will not work as initial value. Sorry about that. Now, like reduce, there is reduce right. So what it does is that it is like reduce, but it operates from the right side. So this will calculate 2 to the power 3 to the power 4. It will first compute 3 to the power 4, and then 3 to the power 4 will be how much? 3 3 ja 9, 9 9 ja 81. So it will compute 2 to the power 81, which will be a large number. It will get reduced to some garbage. Let's make it 2 so that it remains same. So if you run this, it will print 412. Okay. Now let's connect this out and okay, let it be there. Now we look at flat. So what flat does is that it flattens one level of array when passed with no argument. So, and it returns the array as well. So A dot flat will flatten one level of array. That is, it will flat from 2. And when you invoke it twice, it will flash 2 and 3. And when you invoke flat dot flat dot flat, it will flatten the entire array. So let's see this in action. There you go. And if you supply an argument, then it will flatten that many levels. As you can see from this example, depending on the argument, it will flatten those many levels recursively. So very simple. Now there is another method called flatmap. So what it does is it allows us to map input elements to any number of output elements. So it is like invoking greetings dot map some function dot flat. This is the basic stuff. So the function in this case is the arrow function. Okay. So that's what it does. So in this case, it will print hello, comma world, comma hello, comma Shiv, comma Shankar, comma Dayal. So that's what it will do. So let's see this in action, and that's the output. Now flatmap also allows you to map input elements to empty array. So this will mean that this empty array will be not in the output array because flat will remove this. So for example, here we are computing the square root of numbers, and for negative numbers, we are outputting empty array. So flat will flatten this. So this is our function. Okay, this is our function of map, and after that it will be flattened. So let's see this in action, and there we go. Next function is concat. So concat does not modify the array on which it is invoked, but it returns a new array. Okay. The second point of interest is that it flattens one level of input array. Okay. So we'll see this how this works. So we have an array 1 to 3. We concatenate 4, 5, and then we pass two arguments 4, 5, 6, 7. Both are arrays. Okay, and then we have another array in which we have 4, 5 as array and 6, 7 as one more array. So let's see how this works out. So there you go. The first is 1, 2, 3, 4, 5, and then we have got 1, 2, 3, 4, 5, 6, 7. So one level of arrays will be flattened, but two levels won't be flattened. So in this case, the outermost array will be flattened and others won't be. So that is what concat does. Note that concat is expensive because it creates a copy of array. So you have to be careful. Now we will look at push and pop functions. So push and pop, what they do is, as their name implies, and you might know from your data structure course if you attended in some other language, push and pop are like creating a stack. For example, you can imagine a stack of dishes, a stack of books, So when you push on top, you put one element. Here at the end of array, that element will be added. Okay. And when you pop, you remove one element from the array or from the top or towards the end. You remove from the end. So we have an empty stack. We push 1, 2, and it will return the length of the stack. So it will be 2. And then stack will print 1, 2. Then it will print 1, 2, 3. And when you pop, it will print 3. It will be 1, 2. But if you put an array, it won't be flattened. Push doesn't flatten arrays. So it will be 1, 2, 4, 5, and then 4, 5 will be popped. And what you can do if you want to flatten one level of array is you can use spread operator and then just do it from the stack. So it will be 1, 2, 4, 5. Let's see this. That's the output which you can see. So as I said, it won't flatten the array, but spread operator, if it is used, it will flatten the array. Note that spread operator will work only for one level of arrays. So in case you want to concatenate arrays, then that will work. Next is we implement a queue using shift and push. So what shift does is shift will remove one element from the beginning. Okay, and unshift pushes one element at the beginning. They are the counterparts of push and pop. Push and pop operate at the end, and shift and unshift operate at the beginning. So as you can imagine, if you operate at the beginning of the array, the indexes of all the elements will change when you push, when you shift and unshift. So since the indexes of all the elements are changing, these are very expensive operation, O1 operation. Push and pop are, ON operation. Push and pop are O1 operation, but these are ON operations. So you have to be careful about these functions. So here we push 1, 2, we print 1, 2 here, Q, then we shift. That shift means 1 will be removed from the beginning and Q will be 2, then we push 3. So at the end there will be 3, and then we print, and then we shift again, then we print again, and we see how this will work out. So 1, 2 was initially there, we shift, we get 1, then the Q will be 2, then we push 3, and then we shift again to get 2, and then we have 3, which is shifted again to get an empty array. Unshift is counterpart of shift, so what I will have to do is I'll have to comment this out. Okay. So unshift will push 1 and then it will push 2. So the array will become 2, 1. Okay. But if you want to put 1, 2, then you can supply 1, 2 both at the same time. So let's see this in action. There you go. So with this, we come to the end of this video. In the next video, I'll show you more of methods, and next video will be the last video on array methods. And after that, we will wrap arrays probably in another video. So there may be 2 more videos on arrays, and then we will move on to function. So I hope that you are finding this video and information useful, and I hope that you are enjoying the entire playlist. So I'll see you in the next one with more on arrays. Till then, I'll take my leave. Happy programming.